It's STEM with Cobb. People are steamed about all the excess CO2 we're emitting by burning fossil fuels. That CO2 traps heat and causes climate change. But come on, CO2 is only 0.04% of the air we breathe. That doesn't seem like much. However, commercial truck drivers can be arrested for driving under the influence if their blood alcohol level is 0.04%. And 0.04% of cyanide in your bloodstream can kill you. It just depends on how the chemical interacts with the whole system. So let's stop messing around and let's clean up. To do so, we'll probably need to remove carbon. Taking CO2 out of the air is not an easy task, but it's not impossible. To talk about it, we need some carbon jargon. Carbon neutral means we emit some CO2, but we remove as much carbon as we emit. And it's a good start to get us prepared to move into carbon negative. That means we remove more carbon than we emit. That's the ultimate goal. Oh, look what caught Cog's attention. Elon Musk is handing out $100 million in his X Prize competition for carbon removal. Any carbon negative solution is eligible. You've just got to build a system that can directly pull 1,000 tons of carbon dioxide per year from the air or water and contain the carbon in it for at least 100 years. And show how it can be economically scaled up to remove 1 million tons a year. Winners will be announced on Earth Day 2025. Looks like Cog's already getting to work. Okay, Cog, digging a ginormous hole is not carbon negative. That digger emits more CO2 than you could ever get to flow down into the hole. A vacuum cleaner isn't gonna work. Sure, CO2 flows in along with all the other gases in our air, but then it just flows out the back. The CO2 is not contained. Well, Cog, even if sticky fly paper on your drone could catch CO2, it's not economical. Think about how much fly paper you would have to manufacture to remove 1 million tons of CO2. Sorry, Cog, I don't think your ideas are going to win a prize. But lots of important carbon removal projects will. And that's good because scientists tell us we need to reach net zero by 2050 in order to avoid the worst impacts of climate change. Here's a graph showing what we need to do to reach net zero. The red line shows the business as usual scenario where we continue to emit 37 billion tons of CO2 a year. Let's not do that. The blue shows how much we can reduce our emissions by using alternative energy sources and increasing efficiency. Right here, the height of the blue, or CO2 emissions, equals the height of the green, or CO2 removals. We've got to get there. Then we can start removing the 1 trillion, that's right, over 1 trillion tons of CO2 we've emitted since 1850. So let's look at some carbon removal projects already being developed. Some direct air removal facilities take CO2 out of the air using big fans to move air over chemicals that react with and trap CO2. Heat typically releases the CO2 so it can be collected. That collected CO2 can be buried underground. We can mix CO2 into concrete to make it stronger. We can use that CO2 as an ingredient to make plastic. Or we can use it to make synthetic or syn fuels. Those are fuels made of gases like CO2 or methane. In this scenario, we collect CO2, make it into synthetic fuel, burn the fuel in planes, trains, or ships, and, of course, the CO2 goes right back into the atmosphere. But hey, at least we're not adding more excess carbon from fossil fuels. Another way to remove CO2 from the air directly is enhanced rock weathering. Turns out, if you powder basalt, it reacts with CO2 to make carbonate minerals. If we speed up weathering by pulverizing basalt rock, farmers can mix it into soil. The basalt powder captures CO2 and improves crop yield. We're still crunching numbers to see if this is carbon negative or if transporting all that heavy rock emits more CO2 than it captures. But let's not forget the obvious way to capture CO2 from the air: photosynthesis. That's the process where plants, algae, and some bacteria use sunlight to turn CO2 and water into sugars. It happens on land and in water. Let's see. I'm adding 10 drops of bromothiamyl blue to this jar of water. Bromothiamyl blue is an acid indicator that is blue in neutral water and goes green to yellow in acids. Some of the CO2 I'm exhaling into the water will make carbonic acid. The color change tells us that CO2 has dissolved into the water. I'll divide the water into 2 jars. One gets an underwater plant. The other jar is the control. 1 hour later, the water with the plant is back to neutral because the plant is absorbing the CO2. Pretty amazing. We could use this by growing algae in oceans or in ponds on land to remove CO2. When the algae die, they sink to the bottom where they can be collected to bury or to use in the production of plastics, fertilizer, or other products. If we use the algae to make biofuels, fuel made from plants, algae, or animal biomass, the carbon is not stored for a long period, but it does replace fossil fuel use. Planting forests or grasslands can also remove CO2 from the atmosphere. Kids like these students are planting trees and bushes to rewild areas that were croplands or built environments. That's important work, but you can help too just by planting a garden. Share your harvest with your neighbors. Sadly, plants eventually decompose or catch fire, releasing CO2 or methane, which brings us to biochar. If agricultural waste or downed trees are burned at high temperatures with low oxygen, they become pure solid carbon, or biochar. Mixing it into the soil improves the soil quality, or it can be buried underground for long-term storage. We can also use biochar to make graphene, as long as we use alternative energy sources to do it. Graphene is a thin film of pure carbon that can be used to make everything from lighter, faster electronic devices to water filtration systems, sports equipment, and tons of other products. Large-scale photosynthetic projects could help us get to net zero. Another idea is called carbon capture. Whoops! That set off the controversy alert. In this scenario, we continue to extract and burn fossil fuels in factories and power plants. The CO2 produced is captured from smokestacks, then compressed and utilized to make products, or it can be buried. This process is meant to help us transition away from burning fossil fuels. But let's look at this graph comparing processes we can use to reduce net CO2 emissions. CCUS, or carbon capture, utilization, and storage, is not very effective, and its orange color means it's really expensive. But in my mind, the worst part of CCUS is that often the CO2 captured at the smokestack is used by oil and gas companies in order to extract hard-to-reach oil and gas so that we can burn even more fossil fuels. I know. We have to ask, is this just enabling us to continue our addiction to fossil fuels? So let's recap. In order to avoid the worst impacts of climate change, we need to reach net zero quickly. One tool we can use is direct removal of CO2 from our atmosphere. That might look like giant fans or chemical reactions or powdered basalt or big-scale photosynthesis projects. Carbon capture absorbs CO2 before it can be emitted from the smokestacks of factories or power plants that burn fossil fuels. Well, we've just looked at land-based processes that can protect our planet by removing CO2 from the air. And scientists are also developing ocean-based carbon removal projects. But what if we just need more time to get to net zero? Scientists are researching solar radiation modification projects that could lower Earth's temperature. We could reflect more sunlight by using space sunshades or mirrors. Or we could inject aerosols like sulfur dioxide into the atmosphere to mimic large volcanic eruptions. Or we could focus on clouds and manipulate them to either reduce their heat-trapping ability or increase their reflectivity. We might be forced to use solutions like these, but only after much more research is done to determine the unintended consequences. Instead, let's work together and solve our carbon dioxide crisis. We can do it.